We are talking about inscribed angles, and we want to find the measure of inscribed angles, and we want to find the measure of angles of inscribed polygons. So here we have an example of a triangle that's inscribed or an inscribed polygon, and we want to use some information that we know in order to figure out the value of x. So in this case, we know that line segment AC is a diameter, and the reason that we know that is because AC goes through the midpoint P, so this is a diameter. So I'm going to write that on here. So because AC is a diameter, that means that this is 90 degrees, because the only way that that can be a diameter is if that's 90 degrees. So I'm going to put a new point on here so we can name this correctly and call it M. And then we're going to say the measure of arc AMC is equal to 180 degrees. And the reason that we know that it's a semicircle is because it goes through the chord, it goes through the center point P, so it has to be a diameter. So we know that the measure of angle B has to be 90 degrees because this is an inscribed angle and it's half the arc measure. So the measure of angle B has to be 90 degrees because we can take 180 degrees and we can divide by 2, and that's going to be equal to 90 degrees. So that's just a quick check on the theorem that we talked about earlier. Then we want to use the triangle sum theorem because this is a triangle. We know that this one is 90 degrees. We know that angle C is x, and we know that angle A is 3x plus 6. So we can use the triangle sum theorem to calculate the value of x. So the triangle sum theorem says all the angles of a triangle add up to 180 degrees. So then we can say the measure of angle A plus the measure of angle B plus the measure of angle C are all equal to 180 degrees. So we can substitute in the values that we know. 180 is equal to, the value of A is 3x plus 6. The value of B is 90. And the value of C is just x. So we can combine some like terms. We bring down the 180 degrees, and then we get 3x plus x, so that is 4x, and 6 plus 90 is 96. Then we can subtract 96 from both sides of the equal sign, and we get 84 is equal to 4x. And then we can divide by 4, and then we end up with 21 is equal to x. We've got a couple more examples for C and D. We know that we have a inscribed quadrilateral, which is EFGH. So all of the angles of a quadrilateral add up to 360. But if it's an inscribed quadrilateral, we know that the opposite angles are supplementary. So we know EG equals 180, and we know FH also equals 180. So we can say 180 is equal to angle E plus angle G. The measure of angle E plus the measure of angle G. So we can substitute in the values that we know. So we still keep 180 degrees. The measure of angle E is 11x plus 8, right there. And the measure of angle G is 8x plus 1, right here. So we can combine some like terms together. And we have 11x in 8x, that becomes 19x. And then we have 8 plus 1, that becomes 9. And that is still equal to 180 degrees. We can subtract 9 from both sides of the equal sign, and we get 171 is equal to 19x. Then we can divide by 19, and we get x is equal to 9. So that's how we solve for x. Now we need to solve for y, and we're going to do it the same way. So we can say we already did E and G to get x. Now we're going to use H or F and H to get y. So we can say 180 degrees is equal to the measure of angle H plus the measure of angle F. And we can substitute those values in. So 180 degrees is equal to 6y minus 4 plus 5y minus 3. We can combine like terms. So we have a 6y and a 5y becomes 11y. We have a negative 4 and a negative 3. That becomes negative 7. And that's still equal to 180 degrees. Then we can add 7 to both sides of the equation. And we get 187 is equal to 11y. Divide by 11, divide by 11, and we get y is equal to 17. And then we have example D, where we're given this huge figure, and we want to figure out what this angle is here. But it's really pretty simple. Excuse me. We're given the inscribed or intercepted arc of WR as 118 degrees. So the angle WSR is inscribed. So the angle that we're looking for right here, which is we're going to call X, is just equal to half that angle. So we can say the measure of angle WSR is equal to 118 degrees divided by 2, because the inscribed angle is half the measure of the arc. So when we do that, we get the measure of angle WSR is equal to 59 degrees. So in this case, we're talking about X is equal to 59 degrees.